Hey guys, Mrs. Kruger here. Today we are going to talk a little bit about chemistry, and I apologize for the subpar quality of my video, but I'm working with my iPhone, so we are going to work with what we have and we are just going to roll with it. So the first thing we're going to talk about today are elements. So elements are substances that cannot be broken down any further by chemical or physical means. And you have elements all around your house. In fact, one very common element is this right here, aluminum. So elements are defined by their physical and chemical properties. And one of the properties of aluminum is the fact that it's shiny and it's malleable. I can bend it into different shapes. So it's different than other elements. For example, it's very different from hydrogen, which is actually a gas at room temperature. It's colorless, it's odorless, and it's flammable. So that's some of the properties that define hydrogen, make hydrogen different than this element, aluminum. All right. So the next thing I want to talk about are the chemical symbols that are used to identify elements. If we were to look at a periodic table, which we'll do later, we're not going to worry about that today, we would see a bunch of letters on that periodic table. And those letters are what are used to define different elements. So I have some elements here for you to look at and their chemical symbols, some very common ones. Hydrogen, which is not the same thing as water. We'll talk about that in a little bit. It's a very important component of water, but not the same thing as water. Hydrogen, remember, is a gas at room temperature. Carbon, chlorine, so that's C, lowercase l for chlorine, sodium, and oxygen. So these are common elements that I do want you guys to be familiar with by the time we're done with this unit. All right. So I'm going to use these different colored M&Ms to represent elements, and hopefully these are showing up okay on camera here. So the blue M&M is going to represent hydrogen. The brown M&M will represent carbon, the yellow M&M for chlorine, the orange M&M for sodium, and the green M&M for oxygen. All right, what I'm going to do is talk about the difference between molecules, compounds, and mixtures. So an element standing on its own, or one atom, I should say, standing on its own, is considered just an atom. So that's one single atom of an element. That's an element in its most basic form. I cannot break this element down any further. So that's hydrogen. However, if I were to combine hydrogen with another element, that would become either a molecule or a compound, which is a type of molecule. I'm going to combine hydrogen with oxygen to create a very common molecule that we're all familiar with, H2O. So H2O is water. So I've created a compound. A compound is two or more different elements that are chemically combined. And if you were looking at pictures of molecules that are compounds, what you would see are these little lines in between. These lines represent chemical bonds. Chemical bonds are very difficult to break down. So when I draw these lines, I'm showing you that the hydrogen is chemically bound to the oxygen. Here's another example of a very common molecule. So I have two oxygen atoms here, and I'm going to draw a line in between them to represent a chemical bond. So when these two atoms are chemically bonded together, that forms O2, which is the type of oxygen that we're able to breathe in. It's different from O3. O3 is ozone, and we do have an ozone layer in our atmosphere that protects us from ultraviolet rays from the sun. But if we breathe in ground level ozone, that can actually be toxic. So imagine that, just adding one more atom to this molecule right here could be toxic. So here's the difference between compounds and molecules. Molecules are two or more of the same elements chemically combined. So two atoms or more of the same element that are chemically combined, versus a compound. Compounds like water have two different elements. So in this example, oxygen is one element and hydrogen is another element. So those two elements are chemically combined to create this compound. So molecules, two or more of the same element. compounds, 2 or more different elements, versus an atom, which is just one single atom of an element, standing alone. So this would be one atom of a hydrogen element standing alone. So those are the 3 different things that I want you to become familiar with. There are lots of different compounds that we can talk about, and I have some very common ones that I would like you to become familiar with as well. So water is one of the compounds, H2O, and notice that the 2 here next to the H is telling you how many atoms of hydrogen there are in this compound. So I'm actually just gonna erase this and make this a little bit bigger so we can dissect this further. So compounds are written in a set ratio. I'm gonna draw this out. So I'm not using blue. I wish I had blue. I'm gonna use purple for hydrogen this time. So here's H, and then I'll use my green for oxygen. All right. So these lines again represent my chemical bonds between the oxygen and the hydrogen. And when I write out this chemical formula for H2O, what I'm saying is there are 2 hydrogens for every 1 oxygen in this compound. So this chemical formula breaks down the ratio of different elements in compounds. I'm going to write out a different compound for you to see. So this time, I'm going to write out CO2, which is probably something that you're very familiar with. So this is carbon dioxide. I do have a brown for my carbon. So here, I don't have a number next to my carbon. Anytime there's not a number there, that tells you that there's only 1 carbon atom in this compound. So just 1 atom of carbon here. The 2 next to the oxygen is telling me that there are 2 oxygen molecules per every, 2 oxygen atoms, I should say, per every carbon dioxide compound or carbon dioxide molecule. I can also call it a molecule. All right. So here's my oxygens. I'll put my little O's inside. Here's my carbon. I have 1 carbon and 2 oxygen atoms per this carbon dioxide compound or this carbon dioxide molecule. Notice that I drew double lines here. These double lines represent a double bond. That's not something that you have to worry about, double or single bonds, maybe something that we'll get to a little bit later in the year, but this is just representing a stronger chemical bond between the oxygen and the carbon. All right. So if I were to use my little candies to represent a carbon dioxide molecule, I would just use 1 brown M&M. And then I would draw my little double lines. And I would have my 2 green M&Ms for each oxygen, okay? So that's my CO2 molecule. So hopefully you're getting the hang of this, and certainly if this is something that you want to practice on your own and you have access to different things in your house, it can be candy, it can be marbles, anything that you want, you can just draw it out to represent different types of atoms of elements. All right, so we'll talk about a couple other different types of chemicals. One other one that I want to share with you is this very common household item. So this is just table salt. And what's interesting about compounds is the compounds often look different than their original elements. So the elements that make up the compounds are different. For example, hydrogen on its own and oxygen on its own are both gases at room temperature. But when you combine hydrogen and oxygen together, it creates water, which is a liquid at room temperature. So the properties of the compounds, or the properties of the molecules even, are different than the original elements when they're standing on their own. Salt is very different than the elements that make up salt. So chlorine is a gas at room temperature, and it's a poisonous gas. It can be deadly. Sodium is a metal. So it's a silvery metal, and it can actually be explosive when it comes into contact with water. So sodium on its own is dangerous. Chlorine on its own is dangerous, but when you combine them together chemically, it creates salt, which is harmless. Well, of course, in moderate quantities. You don't want to add too much salt to your food. That's not good for your health. So if I were to create a salt compound or a salt molecule, I would need just one atom of sodium, one atom of chlorine. So this is a little bit different than some of the compounds that we've been looking at, because sodium and chlorine have 2 letters to represent the element as opposed to 1. So that can be a little bit confusing. This represents sodium. This represents chlorine. So one way you can discern whether it's 1 element or 2 elements or 3 elements that we're talking about is if it's 1 element, you'll have a capital letter with a lowercase letter next to it, as opposed to my H2O, where I have 2 capital letters to represent different elements. So here, sodium is capital N lowercase a, and chlorine is capital C lowercase l. That looks like an I, so it can be kind of confusing. But this is sodium chloride, which is regular table salt. So I would need 1 sodium, which I'm representing as orange. And then I'm going to draw my little line here to represent my chemical bond. And I would need 1 chlorine, I'm using a yellow M&M to represent chlorine. Okay, so that's my sodium chloride molecule. Some other ones that you might be familiar with, we've talked a lot about methane during our global warming unit, so that's a very important compound. Methane is CH4. So I would write it out like this. So 1 carbon, 1 hydrogen, 1 carbon, 4 hydrogens. The 4 there is representing your 4 hydrogen atoms. And I would put my carbon in the center. And then dog fur everywhere in my house. I'm going to draw my 4 lines to represent my different chemical bonds. And I need my 4 hydrogens. I don't expect you to remember the shapes of the compounds. That's not something that you need to know right now. I just want you to realize that this chemical formula represents the number of elements, and the letters represent the different types of elements that you'll find in a certain compound. So that's really what I want you to get out of this conversation. So we've learned about H2O, we've learned about CO2, we've learned about our methane, which is CH4. So I have my 1 carbon, my 4 hydrogens. And I want to talk about hydrogen peroxide. Remember I said sometimes, or I should say all the time, if you're adding an atom into a compound, it can change the end result drastically. So O2, for example, remember I said that that was gas that we can breathe in. You add 1 more oxygen atom, which creates O3, which is toxic to us, that's poisonous to us. So water is H2O. Hydrogen peroxide, some of you might know, is H2O2. So when I just add 1 more oxygen molecule to water, or 1 more oxygen atom to water, it creates hydrogen peroxide, which is very different than water. Still liquid at room temperature. And the hydrogen peroxide molecule has a really interesting shape. So I have my H here. It's kind of like this zigzaggy shape. I have my oxygen, another oxygen, and another hydrogen. So I have hydrogen, chemically bound to oxygen, chemically bound to oxygen, chemically bound to hydrogen. So there's my hydrogen peroxide. And then another example, much like my salt, this is something I had in the kitchen. So baking soda, sodium bicarbonate, is another chemical compound that is very different in appearance when you combine various elements together versus the elements when they're standing on its own. So sodium bicarbonate contains 1 atom of sodium, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. So I would write sodium bicarbonate out like this: 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. So remember I said sodium, standing on its own, is a shiny metal. It's very reactive and explosive when it comes into contact with water. Even just condensation in the air can cause an explosion. Hydrogen is a gas at room temperature. It's flammable. Oxygen is a flammable gas at room temperature. So 1 atom of oxygen on its own. And then carbon is found in diamonds and graphite. So carbon can have a different appearance depending on environmental conditions. But when you combine them all together, it creates this white powdery substance that we use in cooking. So you use baking soda to make cookies and bread, so it's often used in baking. And a lot of you said you've been doing baking at home, so you're probably using a good amount of baking soda. All right. So hopefully that has helped you wrap your brain a little bit about the different concepts. So remember, elements, just to review very quickly, I'm sure you're getting tired of hearing me, cannot be broken down any further. So an example of an element would just be oxygen on its own. Molecules are 2 or more atoms of the same element that have been chemically combined. So for example, so here's oxygen. O2 is a molecule, as opposed to a compound, which is also a molecule. So a compound is a molecule, but it's just a molecule that has 2 or more different elements that have been chemically combined. So water, is that going to be a compound? Is it going to be a molecule? Is it going to be an element? Water is going to be a compound. I have 2 hydrogen atoms chemically combined to 1 oxygen atom. So I have 2 or more different elements that have been chemically combined. All right, that's it for today. I hope that helped answer some of your questions. I'm going to talk about the difference between mixtures and compounds, elements, and molecules in the next video. So take a break, absorb some of this information, write down any questions you have for me, and I will gladly answer them for you. Bye, everyone.